Download this code and get free GPT-4o from codegive.com, link in the description below. Certainly. The producer-consumer problem is a classic example of a multi-threading scenario where two types of threads, producers and consumers, share a common buffer. The producers produce data and put it into the buffer, while the consumers take data from the buffer. This pattern is often used to demonstrate the synchronization of threads. ##### Key concepts. 1. Buffer, the shared resource between producers and consumers. 2. Synchronization, techniques to ensure that producers and consumers do not access the buffer simultaneously, preventing data inconsistency. 3. Wait/notify, used to manage the state of threads when the buffer is full, for producers, or empty, for consumers. #### Implementation steps. 1. Create a shared buffer. 2. Create producer and consumer classes. 3. Use synchronization techniques to control access to the buffer. 4. Start the producer and consumer threads. #### Code example. Here's a simple example using Java. #### Explanation of the code. 1. Shared buffer class. This class contains the buffer, AQ, and methods for producing and consuming data. The produce method adds items to the buffer, while the consume method removes items. Both methods are synchronized to prevent concurrent access. 2. Producer class, implements the runnable interface. It continuously produces integers and adds them to the shared buffer. 3. Consumer class, also implements runnable. It continuously consumes integers from the shared buffer. 4. Main class, creates the shared buffer and starts both producer and consumer threads. It waits for both threads to finish using join. ##### Important points. Synchronization, the synchronized keyword ensures that only one thread can execute the produce or consume method at a time. Wait and notify, the wait method makes a thread wait until it is notified by another thread. The notify all method wakes up all waiting threads when there's a change in the buffer state. Thread safety, using synchronization ensures that the buffer is accessed safely without causing data corruption. #### Conclusion. This example demonstrates a simple yet effective implementation of the producer-consumer problem using Java threads and synchronization. You can extend this example by adding more producers or consumers, handling exceptions, or implementing more complex buffer structures.